This chapter explains the components and their functions in a parachute system. The parachute system consists of 4 separate components, which are assembled together in one system, commonly called a rig. These components are the harness container, the main parachute, the reserve parachute, and the automatic activation device known as an AAD. The skydiver wears the harness container system, and the skydiver is held in by 3 separate points of attachment. When properly fastened and adjusted, it is virtually impossible to fall out of the rig. Once the instructor has adjusted your rig, do not loosen or remove anything. This is a critical safety rule. On the back of the harness is the container, which holds both the main and reserve parachutes. The main parachute is packed in the lower half, and the reserve parachute is packed in the upper half. There are 2 important safety devices on student rigs: the AAD, or Automatic Activation Device, and the RSL, or Reserve Static Line. The AAD is a microprocessor controlled device which senses altitude and vertical rate of descent. If a skydiver is still traveling downward at a high speed, when he reaches approximately 1,000 feet off the ground, this device will activate and initiate the deployment of the reserve parachute. The AAD is only a backup device, and no one should ever consider it to be a substitute for initiating proper emergency procedures. The RSL is a simple lanyard which attaches between the main parachute and the reserve ripcord cable. Its function is to assist in pulling the reserve cable when a skydiver performs a cutaway from a malfunctioned parachute. Like the AAD, it is a backup device only and should only be considered as such. The main parachute is deployed by a pilot chute, which is packed up in a small spandex pouch on the bottom of the container. The pilot chute is a small round parachute approximately 30 inches in diameter. Initiating the deployment of your main parachute is simple. At approximately 5,500 feet, you will begin your pull sequence with a wave off, arch, sweep, feel, and throw your pilot chute. When the pilot chute is launched, it inflates instantly with the 120 mile/hour wind and begins the opening sequence. The main container is held closed by a curved metal closing pin. When this pin is extracted, the main bag is lifted from the container by the pilot chute. Then, the lines of the parachute are pulled tight and the parachute comes out of its bag. Once out of the bag, the parachute is free to open. The pilot chute, bridle, and bag are attached to the top of the parachute and will be seen trailing behind the main parachute. The reserve parachute opens in a similar fashion, but it is held closed by a metal pin attached to the end of a metal cable. At the other end of the cable is a silver metal ripcord handle that is seated securely inboard on the left front webbing of the harness. This is the handle which activates the reserve parachute. When this handle is pulled, the closing pin is removed, which allows a spring-loaded pilot chute to deploy into the air. The deployment then continues in a manner similar to that described earlier for the main parachute. There is no need to throw the pilot chute for a reserve, as the spring inside it takes care of that action. Unlike the main parachute, the reserve pilot chute, bridle, and bag are not connected to the reserve canopy. After deployment, this free bag assembly floats down independently from the parachute. This is another important safety feature found only on Ram Air reserves. Along with years of airfoil and design improvements, this helps to give the Ram Air Reserve parachute its remarkable reliability. The main parachute is attached to the harness container system by a device called a 3-ring release. This device is a load-bearing release system which allows a skydiver to jettison a malfunctioned main parachute. Once the skydiver has fallen away from the malfunctioned main parachute, he is able to deploy the reserve into clean air above him and avoid a potential entanglement. The 3-ring is a very simple device. On the parachute harness is one ring, which is the attachment point for the risers. The risers are the means which connect the main parachute to the harness through the three-ring release. The main parachute's lines are attached to the top end of the risers. The two smaller rings are attached to the bottom end of the risers, and these rings are threaded one through another and locked into place by a yellow Teflon-coated release cable. These Teflon cables are connected to the red cutaway handle, which is a fabric pillow located on the right inboard side of the parachute harness. Pulling the red handle disconnects the three-ring and allows the jumper to fall away from a malfunctioned main parachute. Always remember that the only way to jettison a malfunctioned main canopy is to pull the red cutaway handle. Neither the AAD nor the RSL or pulling the silver reserve ripcord handle will do this for you. That is why it is important to always pull the red cutaway handle first when executing a cutaway. There is one riser set on each side of the harness, both of which have a front and a rear riser. When viewed from the side, the risers appear as a V, which suspends the skydiver below the main parachute lines. The risers are approximately 2 feet long. A total of 4 line groups exist. One line group goes to each quarter of the parachute. On the back of both rear risers is a metal retaining ring through which the main parachute's steering lines pass. At the end of the steering line is a yellow fabric loop called a steering toggle. There are 2 steering toggles, and they are often referred to as brakes. These terms are interchangeable, and both are commonly used throughout this video and in skydiving lingo. The toggles are both held in place by a narrow Velcro strip. The toggle is larger than the retaining ring, and it will easily stay reachable on the back of each rear riser above the canopy pilot's head, even after the brakes are unstowed and in use. At the top of the risers, the parachute suspension lines are connected, and they should run in a straight and orderly fashion up to the bottom of the canopy. In between the 4 line groups, there is a rectangular piece of fabric called a slider. The slider has 4 grommet holes, 1 in each corner. One set of lines passes through each grommet. Its function is to control the parachute as it opens. First, by separating the line groups from each other during the opening, and second, by slowing the opening just enough so that it is comfortable for the skydiver while still allowing the parachute to open quickly. Most parachute openings take between 3 and 6 seconds from the time the pilot chute is thrown. Occasionally, an opening can be more brisk, and occasionally it will be slower. Initially, the slider is packed at the top of the lines. When the parachute opens, the lines begin to spread apart as the canopy inflates from side to side. This action forces the slider down the lines. In the fully deployed position, the slider should come to rest at the bottom of the lines, just above the risers. It serves no other function at this point. The slider needs to be at least halfway down the lines for the canopy to have an acceptable descent rate. Up at the top of the lines is the main parachute. The ram air or square canopy was developed over 30 years ago, and it is the only type of parachute used in civilian skydiving today. The parachutes that you will jump today have been designed specifically for student use and represent the state-of-the-art skydiving training. The canopy is rectangular in shape and resembles a harmonica. It consists of 9 cells that are actually long, airtight tubes. These are sewn together span-wise to form an airfoil, which can glide at a ratio of nearly 3 feet forward for each foot down. The square parachute works on the ram air principle, needing forward speed to keep it inflated and flying. The leading edge of the canopy has 9 cell openings across the front, each of which is divided in half. This internal support structure is the means that forms the external surface of the parachute into a semi-rigid inflatable airfoil. The suspension lines are trimmed in length to hold the leading edge slightly lower than the trailing edge of the parachute. This difference in attitude creates a glide path which allows the canopy to fill with air and become pressurized internally. The canopy pilot's weight causes the parachute to move through the air so that it stays inflated as an airfoil and subsequently creates lift, just like an airplane wing. The canopy's speed and performance are determined by the weight of the canopy pilot in relation to the size of the parachute. In order to maintain the same predictable and docile flight characteristics for all canopy pilots, the heavier pilots will jump with larger parachutes, and the lighter pilots will jump with smaller parachutes. Full forward speed is obtained when both steering toggles are in the full up position. Likewise, slower speeds are obtained by pulling down both toggles equally. Steering is achieved by pulling the toggle down on the side in which direction the turn is desired. For a left turn, pull the left toggle down. For a right turn, pull the right toggle down. For most turns, the toggle is pulled down to the hip bone and the opposite toggle is left in the full up position. To stop turning, smoothly raise the toggle back to the full flight position. During training, the position of the toggles is referred to in 4 terms. The full flight position refers to having both of the toggles in the full up position. The number 1 position refers to holding both toggles evenly at the level of the pilot's shoulders. The number 2 position, or half brake position, refers to holding both toggles evenly at the level of the pilot's hip bones. And the number 3, or full brake position, refers to holding both toggles evenly down and inward to full arm extension. When fully inflated, the canopy will look straight and orderly. There are several common acronyms for checking the main parachute. One is the 3 S's. Your parachute needs to be square, steerable, and stable. Another is the 3 I's. Your parachute needs to be inflated, intact, and in control. These are explained in greater detail in the malfunctions section of this video and reviewed during the practical training portion of this course.